Welcome to Grit, Genes, or Privilege, an introduction to data science tools for understanding which matters most. The aim of this course is to introduce 9th and 10th grade math students to tools in statistics and data science that will be useful if they are planning to take AP courses in those subjects. The only prerequisite for this course is first-year algebra. I'll be using some features in the Microsoft Excel spreadsheet program, but you won't need to have that program or any previous experience with it to follow what I'm doing. During the first two classes, we introduce a data set that includes the performance of 30 riders in the Middletown Bicycle Rally and 3 variables that help explain rider performance: grit, which measures motivation; genes, which measures natural ability; and privilege, which measures how much parents spent on their kids' equipment and training for the rally. In classes 3, 4, and 5, we look at correlations among the variables and perform simple and multiple regressions on the data set. The regressions give us the parameters of an equation that relates a dependent variable, miles ridden by each rider, to 3 independent explanatory variables, the rider's scores for grit, genes, and privilege. We then use the regression equation to determine how much each of the independent variables contributes to explaining miles ridden. In classes 6 to 9, we look at how the regression equation can be used to predict the results of next summer's rally. We begin with the idea that future rider performance is a random variable. We then consider how multiple trials of a random variable take on the bell shape of the normal probability distribution. We then use the regression equation to build a probability distribution for the number of miles a rider will cover next summer, depending on his grit, genes, and privilege scores. Finally, we use a probability distribution calculator to compute the odds of various outcomes in next summer's rally. Now, the Middletown Bike Rally and the data set used in Part 1 of the course are imaginary. However, the data science tools and methods presented are very real and are being used everywhere today to extract probabilities from data and predict the most likely outcomes for weather, financial markets, consumer and voter behavior, medical diagnosis, and even professional sports. These are also the same tools that artificial intelligence engineers use to extract probabilities, which they call weights, from large databases so that their models can decide how to answer your questions. Part 2 of the course is in development. There we will shift focus from small data to big data, from a data set with 4 columns and 30 rows to one with dozens of columns and 20 million rows, one for each American born between 1978 and 1983. We'll use that database to explore this question: how well do the circumstances in which an individual grows up explain his or her social and economic outcomes in later life? I hope you'll find the course useful and that you will send any questions or feedback you have to me at badgerd@gmail.com.